Last video got real close. Can't go over 10 minutes. Gracious. All right. So, number 2. Anyway, that's how that one finishes off. Number 2. They want us to prove AG, where's F? AGF is congruent to CEF. And they're going to say that AD, which is this one, that's a terrible copy. AD is going to be congruent to CB, and then DC, where's DC? DC, this long leg here, is congruent to AB, and I'm not going to mark that. F is the midpoint of AC, so that's also going to give us this. Now, what ends up happening is you'll notice I've got 1, 2, 3. I've got that big triangle all laid out. I've got this big triangle all laid out. It's ready to go SSS style right now. I'm going to throw out my given. I'm then going to call out that middle line. I'm going to say that AC is congruent to CA by reflexive. And that's going to give me my SSS. So I've got my two big triangles lit up here with congruency. I'm then going to CPCTC the pieces I need to finish this proof. So I'm going to CPCTC angle 1 and 2 together. You'll notice I have a side given to me by that midpoint. I've also need something else. It's going to be very hard to grab this side. I don't want to do any segment addition postulates to grab this side. I'd rather do something a little easier. You'll notice that they give you angle 3 and 4 labeled. There's a reason. They're vertical. So I can grab those for free. This will give me ASA, and they'll be congruent at that point. So I'm going to grab those vertical angles right now. Angle 3 is congruent to angle 4. Vertical angles are congruent. F is the midpoint. This is going to be given right there. Why do we need F is the midpoint? That's going to allow us to say that AF is congruent to FC. Definition of midpoint. And then my last one, I'm going to need to CPCTC 1 and 2. So angle 1 congruent to angle 2, CPCTC, and that will give me an ASA for my triangle. And I've got them all proved up. Looks good. Next page. Got a new printer. Copy looks good. Anyway, so again, your pictures, like right here, I didn't go in. If it's got an R that's supposed to be an angle sign, got a little crazy on that printer. Sometimes it shows up, sometimes it's anyway. Here we go. So the first thing they give us an entire triangle congruency. Then they're going to tell us these two bad boys are perpendicular, and they want us to prove, I believe it's going to be the other side. So they have FHL, they've got the big one is congruent to the other big one, JKH. They're going to say that they're perpendicular. And then they're going to want us to prove this other side over here. So we're going to get these triangles for free, and that means we're going to have to CPCTC a whole bunch of information. So the first thing I'm going to CPCTC, I need a side of some kind. I'm going to throw together, now again, order is important here, FHL and JHK. That's the order. So HL and HK are going to be the CPCTC side that I grab. Why not? I'm going to grab these angles for free while I'm at it. And then I'm going to need something else. Going to have to come prove in. So this is what I'm going to have to prove. They tell me that these are perpendicular. Since they're perpendicular, I can grab, just making sure, LGH and KIH. I can go in and grab angle 2. You'll notice they have all the angles labeled except for this one that I want. I'm going to go ahead and mark that as angle 7 so I don't have to call out that 3-letter name. Just going to throw a 7 in there for myself. Anyway, here we go. I'm going to call that perpendicular. They're going to be right angles at that point. Looks like they use measure 90. Still cool. Works the same way. And then those two are going to be the same, and I'm going to finish it off with AAS. Here we go. We're going to CPCTC all that information that I want. They gave me that it was perpendicular. And then by the definition of perpendicular, it's going to hit at a 90-degree angle. And then I can substitute. This is substitution. This is questionable technique. Anyway, I'm going to call that substitution. It's not or, it should be and then definition of equality. I'm putting that in there. Definition of equality. If you've got to have them be congruent. So once you get them equal with substitution, you're going to use the definition of equality to change it to congruency, and then use it as part of your congruency, AAS. Feeling pretty positive about that. Moving along. They're going to say the same thing. We've got FGL and HIK. So you'll notice now it's these two outside bad boys. They're both on the left, FGL and HIK. So you got to be paying attention. They use the same picture for a lot of different things. And then they're also going to give us angle 3 and angle 6. So angle 3 and angle 6 are going to be congruent, and they want us to prove that FHL, they want us to prove the big ones, and JHK are congruent. HIK. Fair enough, fair enough. So the first thing I'm going to do is grab what I want from CPTCC. So these two are the same. I know that I can CPCTC 1 and 4, and then I can CPCTC this side. At that point, I'm all done. I'm all done. I can go angle, angle, side, finish. So given, this is the information I wanted to CPCTC on my picture. Angle 3 and angle 6 is also given, and I can call that a day. AAS. Handy. See if we having a problem. Oh, it's a double. I'm going to cut it right here, and we'll attack the double on the next video.